Well, let's check the .h file. It descends from UI view controller. So Apple wrote that thing, UI view controller. Inside of that class, they implemented a whole bunch of methods, among which is init with nib name bundle. So if I want to override that method's default behavior in order to do my own app-specific initializations of the state of my world, I still need to call that method so that it does its usual thing. But as soon as it's done in calling, then I can go ahead and do what I consider to be initializing my application. So right here, I've copied the signature of that method. And notice that in the very first line of code, what am I doing? Well, I'm actually calling the parent class's version of this method and passing in literally the same arguments, nib name or nil, nib bundle or nil, that I myself was passed as arguments. So in other words, I ask my parent, do whatever you need to do with these arguments. And then I proceed inside of this if block to do what I actually want to do. Now, unfortunately, SQLite isn't the prettiest type of code to write. What language do you see in here, or languages?
SQL?
Yes. Well, OK, so SQL, good. What else? Objective-C, good. And C, right? So this is where things get a little messy in that the SQLite library that ships with iOS is actually still C-based, which means back our pointers and ampersands and all of this, more so than we see in Objective-C. So let us see what's going on here. So, that was not intentional. I had to say that word. All right. So first we have some mutable array. So what are we going to do here? Ultimately, my goal is to create an NS mutable array that's empty by default. Then I want to load from my SQL database that I dragged and dropped into this project when I created it at home. And I want to do a select on that database, get each of those strings, and put it into this array. So that's the big picture. So here's how I create an NS mutable array, allocating it and then initializing it. Here I have a pointer to what appears to be some kind of SQLite 3 structure. So that's probably a struct declared in what file? Probably the .h file that I imported up above. So now here, what's probably the point of this line? NS string path, NS bundle, main bundle, path of resource, ... So the whole chunk of code is going to, as the comment says, connect to SQLite database. But what is this second line of those three actually doing for me?
The file.
Yeah, it's, sorry?
It's saying the file.
It's setting the file, yeah. So specifically, it's figuring out the path of the file. So if you're a PC user, this is asking the question, is it C:\program files / whatever? It's answering that question. Or in this case, it's probably going to be something like /documents / something. And specifically, the file I want is small.plist. So this just gives me a path, a string. Question? Confusion?
No, you said small.plist. I think it's small.plist.
Oh, yes, thank you. Small.SQLite, exactly. So that's the correct extension. So what does this do? You can infer from the function name, SQLite 3 open opens some kind of connection to that database. It's not a network connection. It's simply it's like fopen in C, if you recall how to open a local file on disk. So how do I now talk to that connection? Well, I need to have a query. So I'm going to go ahead and create an NS string here that's literally SQL code, a SQL query, very simple one at that. Now I'm going to have a SQLite 3 statement structure, or rather a pointer there too. And then I'm going to go ahead and call SQLite 3 prepare version 2, so very well named here, passing in a pointer to the database connection, so which is a pointer to some structure, then passing in this cryptic thing. Well, what is this doing? So this is taking the SQL NS string object, declared 2 lines earlier, and returning it as a UTF-8 string. So UTF-8 is sort of a fancier version of ASCII that can actually support far more characters than we would typically have on an American keyboard. So you can have Asian characters and other characters with accents and so forth in there. So this function just expects a UTF-8 string. So that ensures that what might be ASCII that I typed is actually UTF-8. Ampersand statement is actually passing in. It's actually not passing a pointer, per se. What's it actually passing in? We didn't spend much time in 50 talking about these. So statement is a pointer. So what's ampersand statement? So not value. That would be star. With the address of, so point, it's a double pointer. A pointer to a pointer. The address of a pointer. Now, why in the world would you ever want to pass in not just a pointer, but the address of a pointer? Recall that a pointer is just 64 bits in this case, and it's a memory location. Why would I care where in memory that 64 bits is? Yeah?
Because what you want to do is not necessarily interested in saying, OK, pointer points to this object. You want to make that pointer point to a specific place in memory that
Exactly. Exactly. So in this case, we want to actually change what the pointer itself is pointing at. And to do that, we have to go to its storage location in RAM, change those 64 bits so that the pointer is effectively pointing at some newly allocated structure, or in this case, some kind of statement. So this is a way in C, again, of you could also return the address of a statement object or a statement struct, but if you want to effectively return multiple values in C, you can pass in things by pointer and actually mutate their values, not unlike what we've done in those examples like swapping two values, passing them by reference. All right, and so ultimately, what does this thing do? It prepares the notion of a statement. A statement is something that you can then execute by stepping over it as follows. So while SQLite 3 step, passing in that statement, equals SQLite row. So in this case, SQLite row is some sentinel value. That means here you got back a row. I can then go ahead and get column number 0 from this statement and store the result in a char star called C. Then I can convert that char star to an NS string using this syntax, which we haven't had to do before. And though this story sounds complicated, it's mostly just copy-paste of typical code when you want to go from NS strings to C strings. And then self.words, add object S. And just intuitively, why did I have to convert the char star to an actual NS string in order to execute line 3 there? Exactly. Char star is not an object. It's literally just a pointer, but the collection classes in Objective-C, namely NS mutable string, NS dictionary, and the like, these expect pointers to actual objects, where an object is a descendant of what class? NS object. So that's what's expected here. So we just have to jump through some hoops. So in short, this is a god-awful mess, frankly. So this is why there exist like abstraction layers like them core data, so that you don't have to deal with this kind of crap, frankly, when writing code. This is a little too low level and messy when really we're just trying to express ourselves in terms of getting data back from a storage device. But it's doable, and it is supported in iOS. Yeah?
Is the second line in the while loop functionally different from something like NS string, string with format, %s?
That would, NS, oh, so the second line here?
Yeah, NS string star.
Yep, that is exactly the same, except what you just described, string with format, is what we'd call a convenience method, but it achieves exactly the same result here. Yeah, Zach?
What's the difference between you putting all this in init with nib name instead of the view did load?
Ah, good question. Why put this stuff in init with nib name as opposed to view did load? Does anyone want to take a stab at that? Yeah.
If you reload, you don't have to import the database again?
Exactly. So if you evict the view from memory, which frankly will not happen in this app because there is only one view. Well, actually, I take that back. It could happen if we background the app, or I get a phone call in the midst of it, or a text message. So the view to save memory could be punted from RAM. And so the implication, as Yella has said there, is that if then I then foreground the application again, or I hang up the phone call and I go back to playing this application, well, the view is going to have to be reloaded, which means I'm going to unnecessarily ask the database for those 5 or 6 words again and just do a lot of work unnecessarily. Now, with that said, it's not hard work to do. It's going to be super fast. And so if you are developing a fairly large application and you really do want to conserve as many bytes as possible so that the iOS operating system doesn't say, forget this, you're using way too many megabytes of RAM, I'm just going to terminate you altogether, which is bad for apps and business. Well, then you could say, fine, I'm just going to spend CPU cycles to reload this data later so as to save on memory. So it's just that trade-off that we always saw in 50. Good question. Other questions about SQLite? All right, so I'll wave my hand at the remainder of the code since it's quite like what we saw last week for actually rendering a table view. But recall that a table view, this list of strings in the UI, it pretty much boils down to having a data source and a delegate so that the application can send messages to your class to which you need to respond with answers. For instance, you will be asked, how many rows does your data set have? You need to be able to answer that question. And that's what the functions down there do, methods down there do, just like last week. It's pretty much identical. Any questions? All right, so we've promised for a couple weeks now to peel back the layers of memory management, which have admittedly gotten easier with iOS 5. But unfortunately, a lot of the documentation you see online, a lot of the header files that still ship with iOS, a lot of textbooks or just online tutorials still make ample reference to some of the crossed out keywords here, namely release and retain and such. So we started telling the story last week. When you allocate an object, like an NS string or a student object with alloc, what happens in terms of this concept known as reference counting? In other words, how does memory management work in iOS or in languages like Objective-C? Yeah, so you effectively get not so much back, but inside of the object is stored the secret number 1, which means there is one valid need for this object to remain in memory. So just like in C, you still have the notion of a stack, you still have the notion of a heap, and so when you call alloc, you're grabbing a few bytes from the heap, but ideally you don't want to use those bytes in perpetuity because eventually you'll run out of space, right? The heap tends to grow down, at least as far as we typically depict it, so stack is going up, 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 heap is going down, down, down. So if you never actually free memory, as by calling free in C, or by calling formally release in Objective-C, heap grows down, 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 stack might grow up, 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 and eventually these two might collide, or you're just going to use more RAM than is available to you. So freeing up your memory is typically a good thing. So in Objective-C, how is this done? Well, when you allocate an object up here, it gets a reference count by default of 1, and that means one person cares about it, so to speak. The problem is, though, that as soon as you that in certain contexts, the operating system might decrement that count. For instance, when a method returns, or when the pointer to that object effectively goes out of scope so that no one could realistically have access to it anymore, that memory might very well be reclaimed for you. So how is this done? It's done by this mechanism of reference counting, whereby, again, you allocate an object, it gets a reference count of 1. As soon as that object goes out of scope and you no longer have a pointer to it, the reference count goes down to 0. And as soon as that happens, the operating system can say, oh, I can take back these bytes and reuse them later for something else. But this is problematic because in iOS, where you have very much event-driven programming, you have fairly short methods being called, so you can't keep objects around by way of pointers on the stack because methods are going to return pretty quickly. So objects, so to speak, will go out of scope. So if you want to keep some object around, like a student object, for the lifetime of your program, or in Project 2, if you want to keep a high scores model around, or a gameplay model around, an object thereof in memory throughout the whole lifetime of the program, you need to somehow keep that object in the heap. So how do you do this? You effectively +1 the object. So in the past, literally 6+ months ago, you would literally have to plant that stake in the ground yourself. Upon allocating an object, you would typically call retain, which would +1 its reference count further. And there was this other related mechanism called auto release that effectively would +1 it for you and eventually -1 it for you. But in this case, there was also release, so that when you knew your memory, you were done with that memory, you would then yourself manually call release. So this actually isn't hard. Frankly, it's all about symmetry. If you call alloc, or if you call copy, or if you call retain, the rule of thumb for years was you call release. And it's as simple as that. Well, you can tell these stories quite simply, but in reality, dealing with any kind of memory and pointers, as you may recall from this class or 50, is not easy, right? It's very easy to make mistakes. It's very easy to leak memory. It's very easy to accidentally dereference null. So programmers are not as good at computers at managing memory, seems to be the case over the years. So this stuff was crossed out with iOS 5 so that the compiler and the runtime on iOS actually figures out when to free memory for you, so you can get out of the business of doing so. We programmers still have some control over, though, how memory is managed. So in what context have we seen assign, strong, and weak? In the context of? Yep, and what context specifically in view controllers? In properties. So recall that properties are nice and magical because they allow you to do two things, one of which we never remember. So what are one or two of them? Yeah, Carl. OK, so it allows you to automatically generate setters and getters, thanks to the @synthesize keyword. And what else? OK, good. So dot notation, right? Just the syntactic sugar of dot notation. So we get those two things from actually using properties. But when we generate these getters and setters, we might actually want to influence how they are implemented underneath the hood. So we can specify that the setter actually uses assign, strong, or weak. Well, what does this really mean? Well, when you say assign, literally the setter will just do x gets y. It will literally just do a copy of whatever the instance variable in question is. This is great for things like primitives, ints and floats and doubles and chars, where literally you just want to copy. But pointers always get a little more interesting. So in the case of pointers, you typically want to say strong or weak. If you say strong, strong does a +1. This means I really care about this instance variable, so whatever the pointer actually is, and strong means make